What's up, you freaking geniuses? So in this video, I'm going to teach you how to solve a triangle when you're given just a single angle and the length of a single side, all right? So as you can see, we're missing the longest side of the triangle, right? The hypotenuse, and this shorter side over here. But we are given that this angle is 18.4 degrees. The length of this side over here is 13 feet. And we also know that it's a right triangle, all right? So that's a big deal because since it is a right triangle, that means we can use our trig ratios SOHCAHTOA, right? SOHCAHTOA. All right, so the sine of an angle is equal to the opposite side over the hypotenuse. The cosine of an angle is equal to the adjacent over the hypotenuse. And the tangent of an angle is equal to the opposite side over the adjacent side, all right? So we can use these trig ratios in order to solve for these missing sides. How do we do that? Well, let's see. If we want to use this angle that it gave us, 18.4 degrees, we have to use either the sine, cosine, or tangent of this angle, all right? So how do we figure out which one we want to use? Well, if we want to use the sine of this angle, we're going to have to use the opposite side and the hypotenuse, all right? Do we know either of those numbers right now? Well, this is the angle right here, so the opposite side of this angle would be this opposite side over here, which we don't know, and we would also need to know the hypotenuse, which again, we also don't know, all right? So in this case, we probably don't want to use sine. What about cosine? Well, for cosine, we need to know the adjacent side, or length, and the hypotenuse, all right? So for, again, this angle, we do know the adjacent length, right? It's 13 feet. And we also, in this case, still don't know the hypotenuse, but that's okay. So let's say that we want to use cosine of an angle is equal to the adjacent side over the hypotenuse, right? So we're saying that the cosine of an angle, we'll say theta, is equal to, again, the adjacent side over the hypotenuse. Now, in this case, theta, it's given, right? This is the angle we're using, 18.4 degrees. So let's plug that in for theta right here. So we're going to get the cosine of 18.4 degrees is equal to the adjacent side over the hypotenuse. In this case, the adjacent side is 13 feet. And so we're going to say 13. And the hypotenuse, we don't know. It's just labeled as C, right? So let's just leave that right now labeled as C, all right? So C is what we're trying to solve for, right? So in order to solve for C and isolate it, the first thing we can do is actually move it to the numerator, and we can do that by multiplying both sides by C. So then on this side, the C's on the top and bottom cancel out, and on this side, we're left with C times the cosine of 18.4 degrees is equal to simply 13, right? That's all we have left on this side, all right? So now let's scroll down a little bit. And to solve for C, we can get rid of this cosine of 18.4 by dividing both sides by the cosine of 18.4, like so. So then on this side, they cancel out, and we're simply left with C is equal to 13 divided by the cosine of 18.4. And if you plug that into your calculator, you'll get that this is equal to, let's say, approximately 13.7, and our units, don't forget, are feet. All right, so this is the length of C, the hypotenuse, right? So let's plug that in right here. So we know what C is now, right? It's approximately 13.7 feet, all right? Now, in order to figure out what B is, there's a few different ways we can do this, but again, let's just use our trig ratios, okay? So what do we want to use? Sine, cosine, or tangent? Well, this time we know the adjacent side and the hypotenuse, right? So the only thing that's missing is this side over here, which again is the opposite side, right, from 18.4. So we want to use a trig ratio that uses the opposite side. So that's going to be sine or tangent, right, since we're trying to solve for this opposite side. In this case, I would recommend using tangent because it's going to give us a more accurate answer in this case, right? Because it gave us the adjacent side, what it is exactly. But over here, this number that we got for the hypotenuse is just an approximation, right? And who knows, maybe the answer that we got for the hypotenuse is wrong. And so if we, again, use this number, it's definitely going to give us a wrong answer for the other short side, right? But if we use this adjacent side, since we know exactly what it is, then that means our answer is going to be a little bit more accurate, all right? So in this case, let's use tangent, right? So the tangent of an angle is equal to the opposite side over the adjacent side, right? So the tangent of an angle, theta, is equal to the opposite side over the adjacent side. So in this case, we're going to say that the tangent of theta is 18.4, and that's going to be equal to the opposite side, which is just labeled as b, over the adjacent side, which again is given as 13 feet. All right, so in this case, we're just trying to solve for b, right? This b right here. So the first thing we can do is get rid of this 13 by multiplying both sides by 13, right? So then on this side, those cancel out, and we're left with b is equal to 13 times the tangent of 18.4. Maybe it'll be helpful to put that in parentheses, all right? So if you multiply this all together, you'll get that this is equal to approximately 4.3 feet. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.